Hello, welcome back to the stream where I implement an AI bot for the game Terminal. Once again, we will do a quick recap what this game is about. This is part 3 of my streams this week, and it's the last part. So in the first part mainly we just went through the basics, the rules. We changed the provided algorithm a little bit. Second stream we did some maybe more advanced stuff that is still quite basic. We analyzed some more games, and for today I mainly plan to do some graph related algorithms that will help you analyze the map. Welcome everybody in the chat. I hope you hear me. But so far, if I opened a correct chat, I see nobody. I hope everything is okay. So, as always, quickly about the rules. It's a two-player game like tower defense, where we build on our side towers that defend against enemy units, and also at the same time we send units from our side. There is money that you spend on units, there is metal that you spend on towers, and the game is turn-based. So every turn you build some towers, you hire some units, and then after that all the units go forward towards the enemy edge, and if they reach an edge, they will do some damage to your opponent. Okay, I have some notes from previous streams, and we did some stuff. Our current to-do is understand where to put support towers, what we talked a little bit at the end of the previous stream, and whether we should hire EMPs in the corner. Both these things seem quite important to make your algorithm smart, to make it adjust to the current situation, not just hardcode what happens, but for that it's useful to understand what happens on the map, and we'll focus on that today. So we'll talk a bit about graph algorithms. I was motivated by topic faster pathing algorithm, where someone started a discussion about that the provided implementation where we create some map, some state of game, and then we run the function give me a path of a unit, it's quite slow. So it would be better to improve it, to maybe implement it ourselves, and also to understand where is some corridor, where is some passage that most of units will go through, or maybe just all the units must go through that point. Hello Sazat, hello Chill Music Hits and Simon. Okay, so someone mentioned a star algorithm. It's something that you can read about. There is also an entry here from one of organizers, what he did, so you can check it out later. But now we will do a bit different things, so more algorithm focused. Let me run some game to make a screenshot of a game, and with that I will work with that in Paint or GIMP to show what happens and what we want to do. Okay, that will be okay. So this is how you should expect a map to look like. And here a human easily sees that what a human sees. Well, a human sees that this place is some passage. It's the only place where blue units can go through, and this place is the only such place for pink units. And we would like to make our program understand, make our program find these places. And so first our goal will be to find that. And then we will talk about some algorithm like Dijkstra to find our BFS, to find that closest way to the enemy edge. So for those who are not familiar with rules, here once you hire a unit, you must hire it at along your own edge. It will start going towards the enemy edge, like base, according to some predefined algorithm that is described in the problem statement. So you don't decide how to move your unit. When you hire it here, for example, it will basically want to try reach this place, and here, since some part of the map is blocked with towers, it will go along this pattern. And there are some special ifs that it tries to go zigzag, but of course first of all it tries to follow some shortest possible route towards the goal. So we'll do that later. Okay, first about understanding where something like this happens. So one possibility is to try to find a long line of towers, and then to understand that along this line only a few cells are empty. But it will not work at all if the pattern is complicated like this one, and we also want to analyze how your opponent builds towers. So even if you yourself build towers along some straight line, it's bad if your opponent does something else, and because of it your algorithm will work terribly. So you want to be more elastic. Also, we want to understand if, for example, somewhere here like we can now go through. So for example, some towers here are destroyed, and now units will go here. So it's better to limit yourself to something like this. So here in this problem we'll use the fact that we have two halves. So this is like player 1 territory, and the other half is your opponent. So every unit must go through this area, and except for maybe some very strange situations, it will only go once through this line, the border. It will not likely go through and then go back to go through again. It's possible, but not likely. So it's quite hard if you don't know the exact algorithm for that, but to find the smallest possible gap, maybe constructed by some strange pattern. For example, maybe here there are some more towers, and now we should go through, I don't know, a line like this. So maybe this is this smallest possible gap. So an algorithm for that actually is very strange, because it's to understand how close this left side of border, the left side, is to the right side. So I would say it's counterintuitive, just some well-known algorithm that is quite tricky to understand. So actually, let's imagine that there is someone here, and he can jump he can jump from a tower to a tower, along pink towers only. So he can move from here to here or here, and so on. So he can reach right now all the towers here. But he can't reach those towers. And we say that he can also jump to an empty place, empty cell, with cost of 1. Let's say he doesn't want to be in cells like that. And it will be possible to implement with something like BFS maybe, or maybe Dijkstra. So from this he can jump to this with cost 1, then to the next cell cost 2, and so on. And eventually he will be able to reach towers here after spending some cost, after spending some time jumping through empty cells. And then when he reached this place, we know how many times he had to go through these cells, and now he can easily go here. And such an approach also works if there is some strange gap here. For example, if there is no tower here, what this algorithm will find will be the cheapest possible way to fill all the gaps, to make like your boundary have no gaps at all, nor holes, not holes. For example, it will say, okay, this man right now can jump through this cell, this cell, this cell, let's say, and also he will later have to jump through this cell where nothing is here. So we say that this cell is removed, this tower is removed. So we can build 4 towers to make it blocked off completely. And while we will not necessarily want to block off something completely, it's also important to understand when we want to make some place stronger, when we will know that some passage will be often used by units, and we want to put a lot of distractors there, so towers that do damage. Actually, it's not exactly what I explained, because here, in this game, units can go between adjacent cells. So from this cell, you can go up, down, left, or right. Not not up, left, for example. So actually here, just one tower is enough to block off everything completely, this tower. And to make this fix, so to consider the fact that units go in 4 directions, actually we should allow this man to go in 8 directions, in 8 cardinal directions. So from every place he can go up by 1 cell, up right, right, and so on. Okay, so while it's counterintuitive, the class of problems like this, the class of algorithms where you take a problem and you do something completely opposite, it's called duality, and there are it's especially related to maybe flow problems, flow and cut, or to some simplex algorithms. So anyway, we allow this man to go in 8 cardinal directions, and we ask what is the cheapest way for him to go from left side to the right side. And this algorithm will give us the smallest possible set of cells where we can put towers to block off our half completely. And as I said, we do that not necessarily to block our side, but maybe to put a lot of strength, a lot of our towers around these places. And I will implement this approach. Why did you choose the topic of pathfinding as opposed to improving where you left last time? Do you think custom pathfinding will be in the winning algo? So I think that pathfinding is very useful, and also apparently people are interested in that. And I'd rather not continue doing what I did in previous 2 streams, because with some ideas I can go too advanced, let's say. I don't know how to describe that well, but I don't want to spoil some ideas that might be useful to get to the top. So while we did some basic things, with maybe the smartest things what we did in previous streams was to say that if something is destroyed, then we build a tower behind the destroyed tower or wall. So I think this is quite smart, and some people might not come up with this solution that is very, like, you don't hard code anything here and it will just work. Of course it can be improved, but ideas like that are very valuable, and you can win competition with a lot of ideas like this. So simple things that will work in almost any scenario, and not just saying that, okay, if somebody attacks my left corner, then I will put towers in this pattern, because you might skip some scenarios, some possibilities. What you can do is you can say that if someone attacks my left corner, then I build extra destructor towers here according to some particular pattern. But if somebody attacks me in a different place, then I use that simple that simple algorithm that you put an extra tower behind. So I'd rather not continue with ideas like that, because then it might be useful, very useful for people in the top, while here, and I don't want to do that. This stream is supposed to help beginners and maybe to those who don't have big experience and want to see what can be done, but not really give very good ideas, like changing the whole game. But here we see that it's allowed and even encouraged by organizers to talk about that pathfinding. And I think because I do competitive programming and algorithms, I can show something that is not obvious and is useful. Okay, we'll try to implement that. I will, to make things faster for me and for the stream right now, I will implement in C++, because this algorithm is not related to this game really. It's just about, like, it's called, I would say, finding a cut between two opposite edges, and it will work on any grid and any game where some cells are blocked. You might want to, at some moment in the future, use that in some different game. Of course, notice that we don't use any properties of this grid. We just want to say, if someone wants to pass through a line between this and this point, then how to block him off with cheapest possible cost. Okay. So let's move that to the left. And so here I will implement in C++, but I will try to explain everything that can be, I don't know, different in Python. For example, maybe there will be a set structure or a pair or something like that. So this is just basic C++ template. And here we can write code. So let's say that this code will, from the input, read the state of grid to know what cells are blocked and what cells are empty. And what I will do is I will consider a rectangular grid, or maybe a square grid. But we can just mark all cells here as empty, and it will be equivalent to the state of game here. I just want to be more general. With this approach, with considering rectangle, you still can apply it here. You will just fill only some cells inside the rectangle. So let's say that, I don't know, we read the size of the grid. Maybe. So this will be the given grid itself. And here we read grid. Okay, so now grid of row column will give us access to a cell in row and column. Actually, in this problem, first we are given x and then we are given y coordinate. So to make things less confusing, let's do it the same way. So we want to do it grid x, y, and x equals 0 is at the bottom. So what we want to do here, from x is, at the very top, x is equal to n minus 1. Here, if we do something like this, so here we read in the input one row, but actually we want to read, well, x denotes one column. So we want to switch that a bit. So maybe after reading, what I will do? Well, I can transpose a matrix. I can like mirror it, and it's quite easy to do. So with this method, by iterating over every cell and swapping it with a cell, like mirrored cell, we just change coordinates. Like we make the first coordinate to be the second one, and so on. And to be sure that everything is correct, what is here? Let's print, for example, grid of 0, 2 to see if it's correct. And let's create some sample test, like some input test. So let's say this is like a grid of size 4 times 4, and this is our cell that we want to print. And also let's fill some other random cells. Okay, and let's see what our program will print. So we run it on in, and unfortunately it prints 1. So I wanted it to print this cell while it printed this cell. And let's think, why is that? Maybe I shouldn't have done this swap. So first I read grid of n minus 1. So this is grid of n minus 1. And then I swap coordinates. So this row will be everything that has second coordinate n minus 1. So this looks correct, I think. Okay. And 0, 2 should indeed be this cell. 1. We printed this. So apparently, okay, I think it's okay, because grid takes x and y. So actually we want, with x equal to 0, y equal to 2 is exactly here. So I made a mistake while thinking what should be printed. And let's print some other cell. Like, it's some very simple stuff like that is useful when you are going to create a more complicated program, and if you write everything, likely it will not work the first time, and then it's very hard to debug. So I can just go bit by bit and now see if I read correctly, and then move towards harder stuff. So I want cell with x equal to 3 and y equal to 1. 0, 1, 2, 3, so it's this cell. Okay, I think it's okay. So now we have our grid, and let's say that let's put an assert that n is even. We want it to be a square where two halves are of equal sizes. So this assert in C++ gives you a runtime error, like segfault breaks when this is not true. So now we are sure that n is even. And now the actual algorithm, what it will be. We want to go, let's say, between this and this cell. So let's say that we call it a cat, because like this is a similar algorithm, this is a related name, from this cell to this cell. What is the coordinate of this cell? Well, x equal to 0 and y equal to n divided by 2 would give us, I think, exactly this cell. Yeah. And the opposite cell, so this one, is n minus 1 x and n divided by 2. So we have cut from this cell to this. And now what we want to find here is the like the list of cells that should be filled in order to cut up the upper half. So let's say that hash denotes a tower. Okay, and maybe let's create a slightly bigger grid, maybe even 8 times 8, because then we can test more stuff. Okay, so we want to go between this place and this place, and let's say that the current situation is the following one. Okay, so we want our program to find that this is a cell that should be filled. Of course, if we know that only one cell is like a gap, only one cell is a passage like this, then we can apply some different algorithm. For example, we can just try every cell in the grid, and to see if we put a tower there, then there would be no path from bottom to from top to bottom. But like, what happens if something like this is the situation, or maybe two adjacent cells should be filled? We want our algo to be more adaptive. But first we'll test it on a simple example like this. So we want to find out about this cell. Okay, so what we do to find close cheapest way from here to here? Well, when there would be no towers and we just want to find the cheapest possible way, the easiest algorithm here would be BFS, because we say that going to adjacent cell has cost 1, so we don't need Dijkstra. Dijkstra is useful when costs can be bigger values. For example, this edge costs 2, this edge costs 5. In other words, going to this cell from this one costs 5 or something like that. Here we only have, like, everything is the same, costs of going to the to the adjacent cell is 1, so we can apply BFS. Let's move n to be global. And how to run BFS? Well, I create a list of pairs. Let's say it will be what I want to do here. So this will be already visited cells to which he can already go. So let's call it like let's say that it's a queue. Just for of course I could use a queue in C++, but let's just say that it's slow, and vector gives us more possibilities. I don't know, I think I can call it just queue. Okay, and at the very beginning in queue I append a pair x1 y1. Okay, so this is append, and what I do now, I iterate over stuff in queue. I have some pair q of I, and now move from P to adjacent cells. But actually here the issue is that our problem isn't really find the shortest path from some place to some different place. What we want to do is to say that we can go for free to some like to adjacent towers, and with cost 1 we can go to an empty cell. So it's a bit different. So we must modify this BFS a little bit, and the easiest way I think will be to create a list like this, a queue like this, for every distance. So here what we want to say is that let me reverse a little bit. Okay, so here we want to say that some towers have cost 0, then some other cells have cost 1, and so on. We want to go with layers. Okay, so first, how to do it in the easiest way. There is a rule, a general rule about programming that says think twice in order, like, so that you would only implement once, or something like that. That is very useful. I recommend that. So I think we have to add one more dimension here, maybe. It will become quite complicated with time. So here we have in multiple lists. Maybe it will be easier to say that this is an array of queues. So let's do something like this. I don't recommend using constants in places like that, because you don't want, maybe you will want to later apply it to a bigger grid. Here I want to make it easier to read for you, because using here vectors of vectors of vectors will become complicated. So here just this would be a list of pairs, a queue of pairs, and here we have an array of that. And like to the first layer, well, let's call it layer. To layer with distance 0 we add this, and now we iterate over distance. And while we have something in this new layer, now we iterate over pairs in this layer. We have some cell, and from this cell we want to go to adjacent cells. And there are a few ways to implement that. One way is to iterate. So we said that we want to go in 8 cardinal directions. Yes, so for this cell we want to allow to go to this one, this one, this one, this one, and so on. 8 adjacent cells, also touching this cell with corner. So one way is to iterate over delta x and delta y. If both these deltas are 0, then continue, because we don't want to go from this cell to this cell itself. And now a new cell will be, well, here we can say that x is per first and y is per second. And here we say x2 is, well, not x2, because we have something like here. Okay, so maybe let's say that the function receives a cell start and end. And then we can use x2 and y2. So here I want to write x2 is x plus the dx, y2 is y plus dy. And now we consider going to cell x2, y2. So this is a very good way to implement that. It's a general advice when you have some problem with a grid. The alternative is hard coding these directions, and it's actually not that hard. So you just want to say what are deltas of x and y in every direction, and it would look something like this. I'm not going to use that. I will just say how it works like. I missed one value, I think. We'll fix that in a moment. Okay, so I'm missing a 0 here and -1 here. So first we have direction -1, -1, that decreases x and y. Then we go to the left, so -1, 0, and so on. So basically we follow a clockwise pattern like this. And here with this pattern you will see that delta x is -1, -1, -1, 0, 1, 1, 1, 0. So this is what I wrote here. And delta y is similar. So you can, the alternative for stuff like that is to here iterate over direction, and here use dx of dir and dy of dir. Here it's easier, and you will not make a mistake like more often with this method, but I recommend something like this, hard coding directions, if you want speed, because like once you write this, you have solution that is as fast as possible, because it will just iterate over this. Here you have some for loops that consider a not necessary direction, and also these operations also take some time. Of course, very small time, but sometimes you care about speed a lot. So I recommend this method. I didn't see chat for some time. I just joined. What is he writing? Why is he writing in C++? I thought terminal was Python only. Yeah, so quickly about what we're doing today again. I want to show some pathfinding algorithms, and those are not necessary for this competition. You can use them for other competitions or other problems, even, like, I don't know, maybe if you in your work, when you are to analyze such a grid. What we want to do is, for a given grid right now, to see what is the minimum possible number of new towers you must insert in your defenses in order to block off your site completely. And while you will not likely want that, maybe you will, we do that in order to make our program understand where is the passage that all units will go through, or maybe two possible passages, because an enemy created a gap here in our defenses, and you will want to put some towers there. And I'm writing in C++ because it's my first language, and it's more convenient for me. It's also more convenient than to test it. And it's about showing an algorithm. You're free then to implement it in Python. I think I will do it myself in my program. And also, you should understand it in order to be able to modify it. So that's an important thing, not just use it as a black box. So actually you will learn something while re-implementing that if you want later. And as I said many times, videos from streams, from my streams, are later accessible in YouTube. So you can just pause at any moment and rewrite it in Python. Okay, so here we consider a cell x2, y2. Let's create a function inside. So coordinates must be from 0 to n-1. So if not inside, continue. And now, what we do now? We need some, I think we can make it global array for distances. It's one possible way. So let's create a constant for this. I always use constant nax. Like I think n, big N, can be easily mistaken with n from the statement, and nax is like for me combination of n and max. So I always use nax. So from this moment, this will denote, and I repeat, I don't recommend using many constants in your code. It's better to make it like to read n, for example in this program, it's better to read n and then make all these arrays to have exactly this size. In C++ it would be with vectors, but making it like this is easier to read, and this is also an important thing during a stream, because not all of you should know how to implement in C++. Okay, so here we'll, let's say, visited. So I can use a whole word. Visited will say if we already like considered this cell, if we already know score for him, and his score just means distance from the start to this cell. I don't want to use distance here because I'm using it here in the implementation, and score is also a good word because it's like a score of some cell. I want to, for every cell, find score, let's say. So here, if not inside or it was already visited, then continue. Also here, when we consider the starting cell, we also mark it as visited. Here we changed x1, y1 to start, so we must put it here. So pair is like a tuple of two elements, and first and second access. So access those elements. Maybe in some languages you will have to write of 0 here and of 1 here. Okay, visited of start first, start second. Okay, and here what we do? Layer of, so let's say that distance 2 is distance. So we have some cell, current cell, and we consider a new cell next to it, and we want to find distance to that cell. So it will be this plus 1 or this plus 0, depending on whether there is a tower here or not. Let's remember, we want to say that this imaginary man can go between adjacent towers for free, and it only costs him to go through empty cells. So if grid of x2, y2 is a dot, so an empty cell, then we increase this 2 by 1. And now to layer of these 2, we append this cell. Okay. Actually, because of how this BFS works, I need to put visited here. I will explain that in short. So you might some idea I had was that I will want to put visited here, and it works if BFS only works for edges with cost 1, but here we have edges with cost 0. And maybe it would work on this particular problem, but it's a bit dangerous. I can think about that later. The thing is that it's bad if if we consider some cell, maybe a tower, maybe not, then we see some adjacent cell, and we see, okay, it wasn't considered so far, so we know that its distance will be my distance, my score, plus 1. And we put it in the next layer, so the list of cells with distance bigger than 1, and if we mark it as visited, we kind of forbid in the future to improve its score. While maybe also there is some edge with cost 0 to this cell, and so we should put it in the same layer, in our current layer. Here, because of the nature of the problem, if from some cell there is an edge with cost 1 to the other edge, then it means this other edge is empty. This other cell is empty. So there will be no edges with cost 0. And I know all of this might sound complicated. It just shows that you must be careful when edges are not only cost 1. So here I claim that it would work, but I want to be more careful, and I also want to consider the fact that maybe I will want to change this BFS sometime in the future. So this is a bit slower, but more general version. Slower because we can put the same cell in these layers many times. In fact, 9 times, because from all the sides. So a node, make the x2, y2 is true. So if you want to make it faster, maybe I will turn it on later, but I don't want to risk forgetting it and then changing my BFS, so it would not work for edges 0. So back to a problem. When we consider a cell, we mark it as visited. So since a cell can be many times in layers, if it's already visited, then continue here. We don't want to consider the same edge many times. And now I think it should work. Also, if make pair of x, y is equal to end, so we already found score for this end cell, we reached this cell, then we break. We want to even break from all the loops here, so I think we should use go to here, that is quite ugly. I will just make some strange hack that is also ugly. How to do it? Okay, you shouldn't care much about that. It just, from here, I want to break also from this loop, so I just change distance to something that will be empty here. I also could maybe let's create flag that's everything is done, computed. Let's here change it to true, and we say, I don't know, if flag done, break. So this should be fine too, and it's less ugly. Okay, let's resolve the compilation errors. Also, I think here I compute these two, but I don't really mark his score. Maybe I should. Y2 is minimum of current, and this two. And since I use minimum here, so initially all the values here are 0 by default in C++. So here this would not do anything. So first I will initialize that to infinity. Let's say, let me create a constant infinity. So this is like 1 billion, and only his score of starting pair is 0. Okay, and I lack int here. And it's compiled successfully. Hello everyone, hello Cold Gamer. Okay, it's compiled. So for starters, let's print the score, so the distance of the ending cell. Previously I created some input file for which I expect that what I do is I ask about the cheapest way to go from here to here, and I expect the answer to be 1 because only this cell should be added. And let's run that. It's indeed 1. Let's change one more cell to empty. It's indeed 2. Okay, what about changing this cell? I think that the answer should still be 1, because we say that this man can go between these two cells. And it's 1. What about making some complicated pattern that will block off everything completely? It should be 0. Okay, so we know the answer in terms of how many towers should be added, but we also want to know the positions. Well, of course, still there could be some bugs here, because running it on a few grids doesn't mean everything. Well, maybe I will create a new grid, and here let me create an empty grid, and let's see if the answer is 8. It's 7. Why is that? Okay, so it doesn't matter. Let's notice that we never check what is the state of this beginning cell, I think. So what I should do here, if this starting cell contains a tower, then it's 0, then it's free. But if it's empty, then it's cost 1, because it costs 1 to make man enter this cell. So let's say if grid of start first, start second is empty cell, then make it 1. Now we use starting distance here, and also we start from layer starting distance. I think a bad thing here is that we start from distance 0 here. I think it should be now from the starting distance. Let's see. It should be now infinity, I think. Yeah. So we start from distance 0, and the program sees that layer, so a list of cells with this distance, is empty. So here it should be starting distance. Now it's 8, and first grid is still 0. So I managed to find still some counter test. So I didn't know that it will not work for this. I just noticed what will happen. So I know that the answer should be 8 here. But it should show you that running it on a few tests doesn't mean everything. It doesn't mean your program is for sure correct. What would, if you want to test your solution like this more carefully, then what I would do, I think, is I would try to create a lot of small random grids like this, but maybe 4x4, 6x4, something like this, and also implement a brute force approach that tries every possible cell and checks if then everything is blocked off. So then the complexity would be maybe 2 to the number of cells in the grid, because it tries, for example, putting a tower here, putting a tower here, and seeing if everything is blocked. So this would be very bad complexity, but it would help you testing your solution. And if you, for example, if you implement something like this in your big program, in your whole Python solution, and something is wrong, then consider extracting this small part and testing it like this, or just making some small unit tests for one module. Hi, Dezionkuś. Can you quickly tell what you're doing right now? Yeah, sure. So we want to understand in the map where is some small gap that should be focused on. In short, we want to know what is the minimum number of towers we must put to block off our opponent completely. So right now it would be just this place. It would be enough. And now pink is completely blocked off. And the idea is that if we know places like this, we know where to put support towers, maybe, where to put distractors, because if we understand that this place is the important place, then we should somewhere around that build maybe, I don't know, here, build support and distractors. So what we did so far is wrote some complicated BFS that knows the best way to go from left to right side. If we say that we move along towers with cost 0, this way we find the smallest possible passage. And now we want to also find these cells. So right now, for example, for this grid, we know that this is blocked, and right now our program will say, it should be here. Our program will see that we can buy 2 towers to block everything, and now we want to also know what towers, where to put towers. So just for myself, I will copy the program to some temporary file. In case I mess up something. And now let's make it even more complicated by by adding the list of cells. So there are generally two approaches for that. One approach is to change his score. So right now his score is just int that says distance from the left. So in this map we would know that score for towers here is 0. Then cells here have cost, have distance, so score 1, then 2, and so on. Here I think it would be 3. Well, actually 2 or maybe 1, because we can jump here. So one approach here is to change this int to some more complicated structure, something like per int and previous cell. So this would be also a per int. So instead of just knowing what is score, we also know from which cell we got here. If you want, after the stream, to learn more about this approach, I recommend you to trying to find on YouTube battle code tutorials, maybe lectures. And one of those lectures is about pathfinding. I think it's this one. And in particular, maybe I will find a place. Okay. In particular, this guy explains it with a program that shows arrows. If you want to go cheapest way from some place to the other place, then from every cell in what directions we should go. And there are some nice explanations of that. I will post here in chat a link to that. I think it's very useful if you see something like this for the first time. So, okay. So, it's about right now in our program, we just know the distance from the start to every cell with BFS, but also we can add this direction thing to know from every cell where to go. Okay, so the idea here will be that we are at cell end first, and from this we want to know what is the previous cell. So from which cell we got to cell end in order to get the maximum possible score. Okay, so I said this is one approach. The second possible approach is to keep it like this, so to just know the score for every cell, the distance from the start, and then how to do it. Then, for example, let's say we have some distances. I don't know. This is not a very good example, but let's say that this is a small grid. We start from this cell, and for some reason this is what we got. So for every cell we know the distance from the start, the closest possible, the shortest possible path. It isn't here true, but because from this from start we can go to this cell in one step, but I just want to explain something. So if you want to get here, so to cell that has distance 3, we want to know how we got here. So we have run BFS, we know distance from for every cell, and now we want to know how did we get this 3. Well, we can take a look at adjacent cells and to see, okay, apparently this cell has smaller distance from start, so we know that we can go in optimal way to this cell and then from this cell go to this end cell. We can do the same here and here then. So for every cell starting from the end cell, what we do is we check adjacent cells for something with distance smaller by 1, that distance computed from the start, the score in our code, and we go to that cell. So we kind of move backwards. And once again, I recommend later reading, well, hearing, watching about it here. So this is one approach, and let's use this approach. So create a path, that optimal path. Okay, I think we'll not do it because we have edges with distance 0 here. So it kind of creates loops here for... I closed it already, never mind. So if we have some distance from the start, we will not necessarily find an adjacent cell with smaller distance, because there could be a bunch of tower cells that have all the same score. So I think we'll go with that more complicated approach. So this his score now will know the score, the distance from the start, and the previous cell. So from which cell we got here. Okay. So I must do some changes so it would compile it at our code already created. Okay, and here instead of just minimizing it with dist2, we say if dist2 is smaller than current his score, then his score first is dist2, and his score second is the previous cell. Actually, now that I think about it, it's bad to do it like this. We can just create a new array. It will be, I think, easier to read from which cell. So, from which cell did we get to this cell? So here we again remove those first. And here, instead of his score, we use from which cell. Okay, and now create a path. So this will be a list of cells. Let P be the end cell. And to path, let's append P. And while P is not start, what we do is P becomes from which cell of P. And path append P. Okay, so now I expect this to contain this optimal path, but from the end to start. So let me reverse it, and let's print it. Okay, we got some path, and so here first let's analyze it by hand. Let me copy it and put it here. So 0, 4 is here. Then we move to 1, 5, 2, 5, 3, 4. So here it told us to build a tower here. Then 4, 5, 5, 5, 6, 4, a tower here, and 7, 4. So it works in this example. Let's also check it for an empty grid. It did something quite strange, but I think it works. So it starts from 0, 4, 1, 2, 3, 4, then 1, 3, 2, 2, 3, 1, 4, 1, 5, 2, 6, 3, and 7, 4. So it's quite strange what it did, because we might think, well, it's easier to do it along this line, but it's still correct. This is the minimum possible number of towers that we can buy in order to block our half. What we should do in order to avoid strange situations like this? Well, we can I still can't pronounce this word. Put priority to adjacent cells along 4 cardinal directions. So what I will do, well, first let me do something for my convenience. So here not only we print that, but we also change the input grid. And now let's print how the grid looks like. So we move from y equal to n minus 1. Here let's change grid of this place to t. So here I just print the grid. And now I will not have to analyze it each time by hand. So yeah, we got the same drawing with strange shape of towers. Actually, here I marked with T everything on the path. I only want to say where we buy new towers. So I will say if grid of this place is an empty cell, then do that. And now here we exactly see where the program bought towers and where there were already blocked cells, like old towers. We can also block some more cells to see if everything works correct. And yeah, it just like nothing happens here. And for example, if we also put a tower here, then we don't anymore buy a tower here. Okay. So what now? We want to avoid situation like this. So what I think is enough to do is to, when we iterate over directions, I think it's better to consider horizontal and vertical directions first. I'm not sure about it. This is like my first idea, but in this case it would just go along a straight line, I think. So how to do it? I don't want to copy paste stuff, so I will do it a bit smarter. Let's make 2 turns of iterating over directions. Actually, right now it would be easier to do what I said at the beginning, because when we hard code the directions like this, we decide the exact order in which the directions will be considered, but I'm going to now stick to this approach. So we do 2 turns of iterating over direction, and if turn is equal to 0, so if it's the first turn and the x, let's say, and not vertical or horizontal of dx, dy, then continue. And similarly, let's say if turn is equal to 1 and vertical or horizontal, continue. And it's good to extract like simple functions like this in functions outside, because it makes the main code easier to read. So vertical or horizontal. When it is vertical or horizontal, if dx is 0 and dy is different than 0, then it's up or down, so return true. Similarly, in the symmetric situation, and return false. Of course, you can also write it as return what? Dx, something like maybe dx is equal to 0, is equal to dy equal to 0. There will be some hack like this that will allow you to make this function one line, but I want to make it easier to read, not necessarily shorter. Okay, so let's see what happens now. And now new towers form a nice line here, and also here we put lines not really in front of stuff, but here. Also, let's see our drawing, and let's try to recreate a part of it. So let's create like 10 times 10, or maybe even bigger drawing, and let's see if for this shape it will also work. So we start here, and what about this shape of towers? Okay, so I want to see if it will work for this more complicated thing. Okay, and it has put a single tower here, as we expected. And what if I remove 2 towers here? It told us now to create 2 new towers here. So I think we are okay. Of course, still there could be some bugs here. Like, I didn't test it very well, but this long code where you can make a lot of mistakes, it isn't very easy, but it will tell us where we can buy towers to like fix our gaps in defense. And I don't recommend relying on just this algorithm. You can't just say, okay, I'm not going to create any pattern from round 0. I will just ask my algorithm what is the smallest possible number of towers I should buy. Instead, you should create some pattern, some smart pattern that you see other people in the top do. And I think this algorithm is nice to use if you want to fix holes. So this is one usage. But the more important one is that here we understand also our opponent's side. So when you create your own pattern, for example, you as pink will create something like this, you know that your units will go through this place. So you can hard code that. You can say that, okay, I will put support here and here. But this algo will also allow you to analyze your opponent's side. What is useful, you will understand more about attacking him. Also, maybe, just maybe, you can modify that to understand where your opponent is stronger. Like BFS like this with layers, with proper changes, will work also if edges have cost bigger than 1. For example, 2, 3, 4. So maybe it's a good idea to say that, okay, if he has a distractor tower, so the one that does damage, then I say that this place has score 3 or something, and then you want to well, maybe I think what I'm saying now doesn't make much sense, because when you want to find a gap like this, you don't really care about the distance from here to here, how strong his defenses are. My idea was that maybe you can use this algorithm to some different things. I'm not seeing right now how, but just maybe it's a thing worth considering. Okay, so what I'm thinking about doing is applying this algorithm for my side, and maybe just seeing, okay, if algorithm tells me, so let's see from the side of a player in the top, if my algorithm tells me that I should put 2 towers here and 1 tower here to block my opponent, then maybe I should, and maybe I don't want to block it, maybe I should just put more support towers or distractors behind this place and on sides. So maybe here it's good to make places here stronger. Let me copy that. So here, from the side of pink, I would consider what is a good character for that. Let A denote something that is maybe, I don't know, a support tower. So maybe right now doing something like this is smart. And I'm repeating, doing your own pattern at first is better, but how the map looks like might change with time. And maybe you will get a big hole in some different place. And maybe instead of trying to cover this and still focusing on your place where you wanted to attack, maybe you, for example, see that you wanted to attack here, so in this drawing here, but your opponent already put a lot of distractors on this side. It's now stupid to attack this place. So instead of hard coding this scenario, what you should do is maybe, I don't know, destroy a few towers in a different place, or maybe not. Maybe you already have gaps in your defense, and then running this algorithm to understand what is a new gap. And of course, it understands if there is more than one gap. Okay, do you guys have any questions right now? So this was a quite complicated thing. If you want me to go through some part again, or ask about something about using this, you can do it. So since I'm anyway showing this code now, so you can rewrite it, it doesn't hurt me to provide you with the implementation. So you are free to use this, but well, you will have to yourself rewrite it to Python if you want to use it during a competition. Okay, and I'm not guaranteeing that it's working correctly. What I mean is that I tested on a few samples, but of course when using it in actual games, if something doesn't look correctly, then you should start thinking that maybe this is wrong. Also, what is important maybe here with these two lines, in some way we decide about the order of directions. So first we consider delta x to be -1, and we consider various delta y. Of course, here we said that first we consider vertical and horizontal steps to avoid this strange shape, to instead say we want to keep straight line. But this order also affects your code a little bit. If there will be some multiple possible solutions, for example, if the situation looks like this, and we go from this left side, then okay, maybe this is a better example. Right now, there are a few ways to put a new tower in order to block everything off completely here. Because you can put a new tower here, 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 and yeah, that's it. So, what I think will happen is we'll go to this cell, and right now, whether we will consider this or this cell, also this one, but we say first we consider vertical and horizontal. So whether we will first consider this or this cell will depend on the order of these loops. And since here we first iterate over delta x, what I think is that in this situation we will put a tower here. And actually, as usually, I want to know if I understand it well. So let me actually test this scenario. And it's very hard to say whether it's okay or not. So what order of loops you should choose? It's just something worth considering. Maybe too much for code bullet change. Yeah, I think it's already too late to now experiment with this and try to apply it if you don't feel well with this code for a challenge that ends in a few days. But one thing is that for sure it's worth using in the whole challenge that lasts till December. And the other thing is that maybe this will give you an idea for some different part of your solution, of your algorithm, where you wanted to find something. And by understanding what we do here, maybe you will see, okay, I can use this actually in that other part of solution. So, well, it's hard to say. So here I said that I expect this place to contain a t. Okay, so actually we say that we want a tower here, and not really. We first got a tower here. So our program seems to first choose this place. And why? Of course, it isn't a big bug or something. It's still well, it works, just not as I expected it to work. So when we are here, we iterate over dx and dy. So first the x is -1, then 0, then 1. So we'll first consider going to this cell. Actually, we'll consider going to this cell even earlier, from the third cell in this row. So actually this T doesn't go from here, it goes from here. Okay, and from here we go here. Okay. Strange. So maybe an issue is that from this place we still must go here, and my program says that instead we can put a tower in this cell and go in the next cell directly. So it's something where we would have to analyze how layers look like, and I'm not going to do that. I'm going to later run my program for this input and print what is inside layers at every step, and this way I will see when exactly this cell is added to some layer and why is it earlier than this cell. I'm not saying that's a terrible thing, but we just have to, if you use something, it's important to understand why something can happen. But well, it's okay that it doesn't break complete. So it will be a to-do for me. Investigate info. So I think when I understand what happens here, also I will put a comment under this video in YouTube, just so you could later see what was the reason. Also, if you want to, by the way, reach me some other way, in the description under the video right now you can see my Facebook page and Discord channel about competitive programming, and in that Discord channel there is also my sub channel for YouTube stuff, so you can find me there. So consider also liking me on Facebook. And what now here? So I think we are done with this big thing, and now let's do something more pleasant. It was some time already that we analyzed some games and talked about possible approaches, so maybe we will do that. Do you guys have any proposals? So here is a list of ideas, and for sure we will not do everything for that. From that, I think we might not do anything more from this list. And for example, we can try to defend with tanks. And first I would have to think a lot how to do it, when to do it. So maybe here corners should be defended with tanks if our corner is weak. This competition isn't something that you should implement in just 9 hours. This is, of course, I would be faster if I didn't explain stuff, but still 8 hours isn't a lot, and I think this is the time I spent so far. Finding breach location and blocking it. Well, I think that this is what this program does. So if you want to, it would be very boring for me now to re-implement that in Python, that's for sure. If you want to find a breach in your structures and you don't want to just follow your pattern to just repeat the same steps, and instead to know what is the smallest number of towers you must add, then run this code. It will give you a list of cells, and then you just put walls there, or maybe towers. distractor towers. Also, since some strange shapes can happen, what is maybe good here to do is to do if enemy side of x2, y2 continue. I don't know, so maybe I will put it in chat so it wouldn't be missed by someone who just misses a minute of a stream. Consider doing something like this when you're trying to find a breach in your defenses, because if side of your enemy is blocked, so if enemy did some whole line without gaps, it might break your side in some way. I'm not sure about that. Anyway, if you want to know if your line is full or where does it have gaps, you should only consider your own towers. You don't want your program to tell you, okay, you should build one tower at the side of your opponents. For example, let's create a smaller sample. If we do it like this, so right now we can add 3 towers to make everything like blocked, but if your opponent has something like this on his side, then I think our program will tell us to build 2 towers on his side. So what I would do instead is do something like this. So while we did it from top instead of from bottom, what you should change if your side is at the top, ball enemy side, and just return y smaller than n divided by 2. I think right now we force our program to build on our side. So I think I will create a new id1 file and share it again. I think this is better to use to analyze one half. But maybe you will want to consider towers from both sides, because they together might affect how some unit's path looks like. Okay, where is my drawing? So here we did one thing, and the next thing that is similar to this one, I think you should do it just by modifying this code, is trying to yourself implement finding a path for your units. I'm not sure about the exact algorithm they follow. It's something like roughly go to the opposite side, at even steps go up or left, like prefer some kind of moves. How to do it? I think the best way is to run BFS from that opposite side, opposite edge, so the goal of your units. Then for every cell in the grid, you will know its score. I can't. I wanted to zoom it in. Okay, so for example, if you know that this cell is, I don't know, 8 units, okay, so if you know then that this cell is 8 units, I don't know, 9 units away, 7 units, 8, something like this. Then after running this whole BFS thing from the opposite side once, now you can simulate how your units move much easier, because when it's in some cell, similarly to what we did in BFS, in recovering the path, the optimal path, we just consider adjacent cells, find something that has distance smaller by 1, so some optimal step, and if there is a tie, then we choose step that is like according to the algo, predefined algo. It's something like at even frame move up or down, at odd frame move left or right. And then after running these BFS once from here, you actually can many times use it to find an optimal path fast from different cells at your site. So it will save you a lot of time. So I think it's a thing that I will myself use in my code. When some tower is destroyed, then you must rerun BFS, because, for example, if this tower is destroyed, then maybe for some cells a new optimal path will be through this place, and this distance to the opposite edge will change. And it isn't a big issue. So maybe some tower is destroyed many times, but it isn't a big deal overall, because it's impossible to create like 100 towers each turn. Each turn will create at most like, I don't know, 10 or something, 5 new towers. So you will rerun BFS only the amount of times limited by the number of towers that were created. So I think the complexity will be okay. So I recommend modifying this BFS thing. Okay, so what to do now? While I think what else to say about this algo. So I feel like watching some games on Twitch. We still haven't finished something that we started in the very first stream. I'm not sure if it's on Twitch or maybe YouTube. But there was a recording from games from some on-site competition. I remember it was hard to find it. Creation, okay. And while watching, maybe I will invent what I want to do next. It just, when working on stuff like this, I think it isn't very pleasant to do one thing for many hours. It's better to alternate between thinking about algorithms, about what you want to do, and implementing. I think this is the most fun approach. Tell me if audio is okay. The bottom right cell is added to the next layer by the previous tower before the current tower, and is hence evaluated first. Okay. Bottom right cell is added to the next layer by the previous tower before the current tower. So what I think is here that this cell is before this cell in the first layer, and because of it, it will push new towers first. So I don't understand fully, Adam. You might be correct, of course. I'm just not seeing it. Chill music hits. I do not know, but couple of messages were blocked by spam blocker. There might be some setting to make it less brutal. Tried to say maybe it was a little too hard, all in all. Oh, okay, sorry about that. I'm sure there is a possibility for that. Let me try to change it quickly. So actually in settings of my stream, it's set to allow all comments. There is an option to limit something, like to try to block some inappropriate comments, but it isn't turned on, so I don't think I can do anything about it, and sorry about the issue. Yeah, I understand that the algorithm is hard. It might help to use it a few times in different problems, in different games, and then you start understanding it well. Because what people usually learn is some simple BFS, and it's a few lines, while here we created something that takes 100 lines, so it's much harder because of layers. But you can just use it as a black box. You know what my code does. You can use it in Python if you have enough time to rewrite, and you can just watch this stream later again to maybe see what places can be changed. For example, I said some things about this order. All in all, feedback is that I will need to return to your code for at least 10 times to make it work. Maybe, like, I'm not saying it's easy. And yes, I implemented something like this many times. While it's hard to implement it, maybe it's one thing is that it's hard to implement it. The other thing was that I was anyway quite lucky to got it right, let's say, first time. I changed some things, but it seems to work on these examples, except for the fact that I don't understand here the order of towers being added, what Adam, I think, explained. But yeah, it's a complicated algorithm. This was also some goal of these streams, to start with basics on Wednesday and to move to harder stuff. Okay, so some matches. So ping has a lot of walls in the front line, and they are indeed cheap, but the question is whether it's okay to allow your opponent to destroy a lot of stuff without actually hitting him. And this is what happens when you don't put destructors in the front line, but on the other hand, if you put destructors, still your opponent can outrange you and destroy expensive destructors. So pink created a pattern when he always attacks through the middle, and I think that blue wanted to move along this way maybe because of his pattern, but he still left this place to go through, maybe on purpose. And yeah, and this is that very important thing where when two front lines are 3 cells apart. So this is a lot of damage and a lot of metal that now the other player must spend, while blue player can spend it on support towers. Yeah, I agree with commentators here. Pink saves some money and then sends a big wave of pings, those cheap units, and he just scores points. Health points of blue are quite low, even though he has a lot of towers and walls, while blue doesn't save at all. He sends something every turn. Oh, he didn't know. I wonder if something happens when two units like go to the same cell, like two units of opposite sides. I mean, your units are in the same cell as your enemy units. Is it allowed? I think so. They still keep attacking each other, but they can be in the same cell, right? Okay. Sorry, I've only seen now. I do not hear audio from commentators. So is it... I wonder if it's too low or something else is broken. I will try to turn it up. Tell me if it's okay now. Did something interesting happen in the stream that I should watch back later? What happened is basically implementing some complicated BFS algorithm, some complicated version of BFS. You can find code in chat above. So it's a long algorithm that I implemented in C++ that allows you to, given some grid, to understand where you want to put towers to block off your opponent completely. And also you can use that to know where is some small passage that all units will go through, and you want to make this place stronger. So it's the first complicated thing I implemented that is quite smart, that adjusts to what happens on map. I think volume was too low, still is. Okay, I will just make it much higher. Boom. Okay. I'm putting a link for everybody if you want to watch later. And also, if maybe the audio is too loud now for some people, do tell me. This almost looks like the same algorithm run against itself. Interesting. Do you not want to compete because it's in C++? No, the reason is that I knew that it would be a complicated algorithm that I will implement for a long time. So actually, I even considered a scenario where I made some mistakes and I couldn't debug it. And since Python isn't my first language, I could do some more mistakes that are language related. So just this is faster for me, and still I can explain it to you. And just I'm going to rewrite it to Python. Maybe then doing some mistakes, but knowing that in C++ it works, so I just have to rewrite it. And I think in Python, to start it from zero and also to then handle some mistakes, it would take me maybe 3 hours, pessimistically. Okay, so the question is, do other people hear commentary?
Helps them out.
Awesome. All right, so McAlga will be moving on to our last round, and let's see, Starwall.
The other half of our finals.
Let's see if something is
Starwall beat our.
So I understand that now I fixed it. So now.
Our
now
previous,
I wonder if you ever
one of our other
heard
contenders,
anything
one of our
in
other
the
top
past.
dogs.
I must check my old streams. So of course, tell me now what volume will be okay. I can do it louder.
So let's see if Oof can take it to the last round.
Oof's going all the way.
Okay.
I can feel it.
Okay,
right.
Sorry for issues.
Let's see what they're doing. See,
early attacks.
this is actually interesting. Another very similar.
I apparently need quite
opener.
a few.
Yeah,
things
they're
in
both
OBS
spawning similar
to run this through.
openers again. They're building very close to the front, sending lots of pings.
So Oof's got a lot of filters protecting his corners there. Interesting.
Yeah, he's using lots of.
Also, he destroyed some filters there and opted to try to replace them with disruptors. That's interesting.
Yeah.
I haven't seen him.
Oh, that's our first remove of the tournament.
Yeah.
That's the first remove.
We didn't see him do that in his other matches, did we?
I haven't seen one.
Okay, I think if you see something like this made by your opponent, then you should be really, really careful by, you should focus on defending this place. 10 chip units, 10 pings sent from here can be devastating. I don't think.
One.
Was that another
I think
response?
one needs very huge
and
defenses
Oof
to get
have the most response.
Yeah, it looks like they might be the most adaptive. You can see Starwall's not building that huge amount of.
And
Oh my god.
What? You didn't notice it was coming?
So, if someone doesn't have big defenses that force your opponent to go along some line and only then go through some strong place, then you're done, with opponents like this. So, it's pattern that should be considered like copying.
Yeah.
No, I was focusing on the pretty colors.
It was a pretty short match. There was a lot of. I think Starwall might be pretty dynamic. It looks like he's sending a lot of pings
Starwall is a god.
to score pretty quickly. This is actually going to be a really
It's strange
interesting
that
final match.
somebody
Both these
heard
bots seem super
commentary
good.
in the previous stream because the
Yeah, he was
settings
just-
were the same.
Oh look! Here are the moves
So
again.
that's what I was saying.
Yeah.
I mean, he was just slowly whittling it down. I mean, here, this is about like halfway through the game, and they're still pretty even
Okay.
health, but
Somebody
Look,
tell
here's
me
the match. Both these bots score
why
pretty quickly.
Blue
This is actually going to be a really
destroys.
interesting
Okay, I
final
think
match.
I understand.
Both these
Or
bots seem
maybe not.
super good.
yeah, it was just
So Blue destroys a lot of things here. So when we watched The Truth Of, I think somebody told me he destroys when towers are
Oh, look,
low
look,
on
here-
health.
Here are the
So
moves
I
again.
guess this is the
that's what I was
issue.
saying.
Yeah.
I mean,
This is
he
the
was
reason?
just slowly whittling him down. I mean, here, this is about like halfway through the game, and they're still pretty even in health. But some like the levee broke at some point, I guess. Oh, it was these encryptors in the back for sure.
Yeah, he sends quite a few over. Okay. Oh yeah, this big wall of encryptors
Yeah,
is
that's-
what really won in the game.
That was,
I didn't notice that.
Yeah,
Cool.
there you go.
Yeah. All right. Let's check out our final round. Let's see if McAlgo Awakens can stop that encryptor buildup that we've seen from Starwall. If he can get past Starwall's dynamic defenses and take another win, and let's see if Starwall can do other cool stuff and beat McAlgo.
Still a bit too loud.
Alright.
Okay.
Chicago just has a strong strategy.
Yep. He's very
Okay.
efficient. He uses his resources
Now
very
maybe it will
efficiently.
be better.
So we're gonna see Mikago's classic EMP train again. Starwall's got a lot of money in destructors early that aren't going to be doing anything because of this big filter wall from Mikago.
Yeah.
But we're going to see the response again with
I think
this
it's
big filter wall.
it's worth
Starwall's got a
considering
lot of
that
money in destructors
here
early that
Pinks
aren't
doesn't try to finish the whole wall first, but he already puts support towers.
gonna be doing anything because of this big filter wall from Mikago.
Yeah.
Interesting.
But we're going to see the response
And
again with
maybe
destructors
his program is so smart that he only enforces with destructors
See,
places
a huge
that
problem
are
for
being
Starwall
attacked?
here is that his destructors are extremely.
It's extremely smart that he doesn't put anything here anymore. Because his opponent his opponent has a wall of towers. So actually Pink indeed doesn't need anything here. Okay, so this is a thing I'm going to copy, I think. If an opponent has a long wall, like line of walls, don't build stuff. Anything on that side, don't build, so stop building towers yourself on that side. Yeah.
Vulnerable to these EMP lines that are really common in the entire game.
Yeah.
A lot of defenses, you'll see them build a few rows back.
But you know, he's doing exactly what I think you should do, which is just pop these really close encryptors and just
Okay.
blow people up.
I mean,
So
realistically, I think,
they
I
both
think
are
there
not
shouldn't
high
be
in elo,
close
so they should not be
firewalls. I
that
think
good.
most
Okay.
spots should try to avoid, like, the front row isn't really a place to put your expensive towers at all.
Yeah, I mean it depends. All right, so let me rephrase that. If I was just an all-seeing bot, I probably would have moved those encryptors from where they are in the right there to the back left. And then
Now that Pink
self-fire that
finished
bot
his
that
wall
got
here,
left open.
His
they
support
also
towers
need
have
So
smaller
you
value
use the,
because they are a
meters
bit
going from the off.
further away
But see,
from
this
the
is what
front
I'm
line.
saying. Like you can really attack that. But I mean, Mikago's down right now, so we'll have to see if he can.
Yeah, Mikago's down
He threw-
to, like, turned there.
Yeah, after Starwall lost his encryptors, it's pretty much done.
Mm-hmm.
Okay. And now with
It's always
this,
cool to see bots,
with
algos
so
that
many
are
support
more
towers,
focused on a late
Pink
game,
has no
efficient
chances. Okay.
strategy,
Game
because every unit you might.
can focus.
to having cores in your pocket because you can respond more dynamically? I'm actually curious if our champions... No, they didn't, but a lot of time if you're playing by hand, I tend to hold on to a lot of cores. So eventually we might start seeing bots algos that try to maintain a big core advantage and hold them in reserve. Alright, good job everyone.
Okay. So you can...
And I hope to see some of you...
You can of course watch this video later, and there is another one. So you can just search for correlation 1 in Twitch, and you will find 2 videos. I think they're still on the leaderboard on some page. Okay. So, for sure, the best person to copy from is the truth of, because he's in the first place. And there are a lot of matches of him, so I encourage you to watch them later, those from forum. So in the previous stream we watched like 2 or 3 of them. I think it's enough, but I'm also going to later watch some more. Okay, and so what now? Soon I will be finishing this last stream. Maybe, I don't know, maybe like 20 more minutes. I don't see something to implement now that would be like beneficial for you to watch, and at the same time that I can show it and it wouldn't spoil something. I spent some time thinking also outside the stream, like yesterday or today, what I can do, what I'm going to do. I didn't have an idea that I think would like break everything and let me win easily. What else? Now I'm just looking at the map, and similarly to when I just solve an algorithmic problem, I wonder what to do. For example, some idea of mine is like we've just seen someone using support towers before finishing the pattern. So I wonder how good of an idea it is and how much damage we can do in the first few turns. But I guess that if your opponent has high elo, so his program is quite good, he will himself quickly build some pattern and you will not easily go through his territory. So I guess that you should also play like steadily with first building a pattern. Will you be trying to go for a win in Code Bullet competition? I think it's too late. I will submit something better that I have now. I'm going to see how much time I have. I mean, how much time I can find in the next few days. So let me see when does it end? Competitions, ongoing. Code Bullet 25th, so 4 days. It is some time, but also I have other things to do. And I'm sure that some people spend long days on this competition, so it's very hard. Maybe if there were prizes for a few people in the top, then I would focus on that because I would know that I'm able to fight for that. But for top 1, you kind of need the best algorithm. You kind of need the best program. So I don't see chances bigger than like 1% for me to win. I beat the truth off, but lost to others lower ranked. Interesting. I copied that and had multiple 1900 plus elo, but well, that is weak. You mean that in the past you had 1900 plus elo, but now it's lower, or what? Because 1900 plus elo sounds like something very good, right? So right now 1900 plus would be something I would be happy with. But still there is some visible gap between the truth of and the next guys. But maybe it's related to the fact that still matches aren't that much played between players with similar elo. So if he beat them at some point in the past, it isn't rerun. I'm not sure if it's still true. No, still, but it is weak to copy. Well, it's good to copy and improve. It's good to copy and then try to beat that, to try to find a counter strategy. So in battle code, competition that happens in January and has huge prizes, like I think tens of thousands of dollars, people in teams compete, and so they have a lot of time. And usually such a team, if they try to win, they create a lot of strategies, like let's say 20, and they like run them against each other. They try to improve each of them. They also copy what they see in leaderboard or visible matches, and they work with that. It's kind of not really automated generation algorithm where they have a lot of possibilities. They try to match them against each other and they counter them against each other, and this way they improve them a lot. It isn't enough for a long competition to just take one algorithm and improve them. And especially it's wrong if you just have an idea and you think, okay, I guess it makes sense, so I will apply it. With some pool of algorithms already written, like different strategies, you can actually see differences from new ideas. Sometimes a new idea will be possible to apply in many strategies, sometimes only in one, but yeah, it's like an optimal way to work in the long run, I think. But for sure, I don't have enough time for that for Code Ballot, but maybe I'm going to do it for December. There's a thread about high-ranked algos meeting low elo algos. I think you saw it last stream. Yes, I saw it. It's how the matchmaking correctly works. Yeah, I'm just saying I don't know if they already changed that or maybe not, but I know that 2 days ago it was an issue. I did not improve it because I do not like the idea of that algo. I wanted to do something else, and I might select an algo that is not on the leaderboard. I still want to find a different strategy that works as well. Yeah, also a different thing is that so there is some randomization part in such a competition, especially in tournament brackets, and if you lose then you are out. And the thing is, well, it's also for ELO style. If there are 20 people with very similar good algorithm, and of course there are some differences, but if their algorithm is similar and is quite good, then each of those people will have very small probability of winning the whole competition. Because let's say he has 5% to be the best among these 20 strategies, similar strategies, and even if they all beat everything else, it's still only 5%. But if you do something completely new, even if it's in some cases worse than those commonly used strategies, still it's something different, so your results will be different, and even if it loses in more situations, your probability of winning is bigger, assuming that you're the only one using this strategy. So this is some more complicated meta that isn't important if when you work on stuff and you just think about new ideas, implement something. But I think it's something cool to think about, and eventually it's important when you decide an algo. Martins just arrived at the stream. Anything hyperparameter optimization, please? Not really, but we made something that understands a map more or less. But I don't really know how to treat a question hyperparameter optimization. So far, I didn't do anything that would work where I would optimize it by changing constants, I think. My only... so where's my algo? So still my algo doesn't differ much from the initial algo. It's something that I finished implementing in the previous stream. And I think the only thing that I should adjust more is... where is it? Oh, here. So if money is smaller than 14, we return. We don't hire anything here. So this is for sure an extremely important parameter. And also, I don't think that this should be a constant. First of all, it should depend on the state of game. I mean, what round it is currently, because later in game we get more and more money every turn, and at the beginning it's quite hard to gather 14. So maybe it should be something like 12 plus round number divided by 10. I don't know. So of course this should be a function that is provided in some module. Last thing I read on one thread about ELO was that for December the highest ELO will be taken as winner, not tournament. Yeah, I know about that, and like it changes things slightly. Actually, in the first stream I talked a little bit about differences in meta between tournament and ELO, but it depends on the way to create matches in ELO. Right now this way is very strange. I assume that eventually you will play against similarly ranked opponent, so maybe then you want to make sure you win against everybody from like between places 5 and 30, while in tournament you should care not to lose against some very common algo that is used by many people in the whole leaderboard, that maybe loses against some smart thing, but you must make sure you're going to win against that. And yeah, and maybe you don't have to care in ELO if you are matched against similar ELO. Yeah, talking about constants, anything general in mind? Well, it's good generally to create constants that you can modify, because then you can like try a few different versions. So at first, when you experiment, it's fine to just choose some constant you feel okay with and you feel it makes sense. But for example, distance of your line of walls from the main border is some parameter that you should try different values of. While in previous streams we like copied some pattern. Actually, maybe it's better to just say that this pattern starts like this, like previously, and then it's a straight line, but where, on what level that straight line is something that can be a parameter, and you can eventually submit a few algos with just a different parameter, and maybe surprisingly you will notice that distance 4 is the best. But it's very unusual thing if we talk about optimization with parameters. Usually they are more complicated constants. So for example, maybe you want to build towers automatically in some place, and you want to count some value. So how good it is for you that this tower will be there. Some moment in the past we said about units, so when bigger size maybe, when unit has some path, I said that maybe it's worth doing maybe something like this makes sense. Mark all the surrounding cells as good. Let's say first we give them some +2 to value. Here it will be +1. Here it will be +1.5. So the other way around. It will be +1 here, +2 here. And with these constants, we increase the quality of cell in terms of putting a support tower there. And choosing these constants is something that is a parameter. And I would first try something like what I would try. Sorry about that. Okay, so maybe something like power of 1.05 comma time. So well, this is C++ way of writing. It just means 1.05 power time, where time denotes like the number of frames that already happened from the start. So if you know how a unit goes, what is a path of a unit in the, let's say, previous turn, then in every frame you mark these surrounding cells that are in range for support tower. You add them this value, and then when you want to create a new support tower and you want to automatically understand where it should be, then you just choose cell with the biggest sum of values that we put there. And of course we need some extra if not to put your towers, like for example pink here, shouldn't put a tower here because it's on the front line, it will be destroyed easily. So with our previous algo our previous algo actually finds a line like this, so it understands what a front line is, and we can say, okay, among cells that are behind it for me, so here I choose a cell with the biggest value. And by the way, I don't know if you agree with me, but this, if I used yellow instead of green, I think it looks like a hot dog. Just by the way. Okay, I feel like even the current 2000 plus truth of does not play that smart, so maybe something that complicated is not even viable. If you have a fixed position that is not based on such a constant, it's easier to test. I agree. I think in code bullets you can win without something like this. So if you don't have infinite time to work on a solution, usually a bunch of ifs is a very good AI, because it works in a predictable pattern fashion, and you understand that you can easily improve that. Those harder ideas are viable for a long run, and also this was something I wanted to show, that this is possible. You should keep that in mind and maybe experiment with that eventually. And it's something that is possible to apply in long contests that also might be useful in your job, depending on your job. But while machine learning, for example, here doesn't make sense, maybe if you have a lot of time, you can apply it on some small part, and this is something that is like more real life useful. Yeah, great advice, thanks a lot. I've been trying to find any info on some sort of optimization based on observations, but so far nothing. Yeah, I'm glad you liked it. Sometime in the future, I'm going to also stream implementing and writing a program that for on optimization problem. So you might know Top Coder marathons, or maybe in Kaggle every December there's a Christmas problem. So then there is some problem, like let's say TSP, travel salesman problem, that can't be done in polynomial time, and you must do it as efficient as possible. So this is also something that I like doing, and I'm quite good in that. And I'm going to stream it and to show some possible like approaches. And while a general approach to that type of problems is just do simulated annealing, there is a lot of other stuff to do, and sometimes simulated annealing isn't like possible to apply. And then those programs usually look like a bunch of ifs and a bunch of try to here optimize it a little bit, swap two values and see if it improves the result. And you can do it in smarter or more stupid way. For the tournament, you could check if the enemy uses truth of starting LA pattern and then counter it. Yeah, it's actually a very good idea. I think you might win like a tournament with that, because right now maybe most of people in the top use exactly that. So if you have a counter for that, and if you add an if to see if this is that exact pattern, you kind of know what your opponent will do in the future, and you can hard code a strategy against it. Can you retrieve a name of algo? Yeah, I guess you are talking about that simulated annealing, so I can write that. Maybe I made a typo, but Google will fix that if you search for that. Okay, sorry, I misunderstood you. So can you retrieve a name of algo, I guess, is about the tournament and understanding how your opponent's name is. Sorry. Yeah, that would be useful. In some competitions, so I participated in some on-site competitions in Poland where there is a game for like 30 players, and you can access ID of some player, and from that you understood who is the first place, so you could copy him. It was one thing. And the other thing, I can share, I think, funny story from one competition, Bubble Cup from like 4 years ago, where contest lasted 24 hours, and one of problems was write a bot for a game with 10 players. And we knew that we are fighting for the first place, so two teams were fighting for the first place, and then there was a huge gap, and the rest of teams fought for the third place. And that second team started to catch up with us. Also, there were some different problems, But on this game problem, they started to be better than us and they got some advantage. So what was optimal for us to do in terms of the whole competition, to maximize our probability of winning the competition, was to encode access their ID. It was possible to do, we knew their ID. And to then, instead of doing something smart, because our algo was second best algo in the whole game, instead we suicided by running our spaceship into their spaceship. We wanted us both to get the last place, to die at the very first round, and because of that they stopped having some advantage over us. So you might find that maybe unfair. So of course it's debatable, but sometimes in order to maximize your probability of winning in the whole competition, you do strange things that don't seem optimal. So yeah, and we won that competition. By the way, it was against some team from Vilna, from Lithuania. If human plays against the best algo, who will win? Right now, I think human, if he has enough time, but eventually it will be algo. Sir, continue to beat the point. Assume you needed to compare two strategies constants. How many games should they play so you can conclude that one is better than other? So, actually, I think it isn't enough to run them against each other, because you will then just see which of them is better against a copy of itself. It's better to run against that if you have a pool of 20 different strategies. So you can check, if you toss a coin 100 times, what is the expected number of heads or tails? Well, the expected number is 50, but usually you will get something like 55 to 45, for example. So once the number of wins is apparently bigger than what would happen from tossing a coin, then you can say that you see a winner. For example, 15 to 5, if you run 20 games, is enough, but 13 to 7 can be still a random thing. Still, maybe it's a 50-50 and it's just something random. But it isn't a bad thing to just run something 20 times and choose the better algorithm. It isn't stupid. It's something better than not checking that second possible one. It is really cumbersome to play by hand, so best algo wins even currently. I think it just takes a lot of time. But if you have a lot of time, if you can do your turn for 20 minutes, I think you will win. Sir, I mean your two strategies with your constants, and of course I'm talking about your opinion, how much would you do? I'm saying that 20 is maybe a good number. If you do 5 and all of them are for one algo, it's then okay, I think, to choose that algo, but you still should know that even if it's 50-50, there is 1 divided by 32 probability that something like this happened. Well, if you're tossing a coin 5 times, there is actually 2 divided by 32 probability that all 5 results will be the same. So all heads or all tails. So it's you can see that it's quite likely still. It isn't impossible. It's far from impossible. Okay, with that I think we will finish this stream and the whole series of streams about Terminal. I want to thank you very much for sticking with my streams, for watching, and what I want to also thank organizers for allowing me for this stream, because, well, still it's kind of bad to spoil a lot of things. Like we don't want people to gain some very tricky ideas from some stream to give a huge advantage for those who watch. But still, I guess it's the same thing on forum. We just can't say too much, right? And I hope some of you learned a lot of new stuff. And my main goal was to give you some intuition, give you some possible ideas. I can also post my notes here. So let me paste that in ID1 as well. And I will give you a link in chat. So you are free to go through that again and to experiment with anything here. If you want to, at some point in the future, maybe 1 month from now, I'm not sure, to see a stream about writing an optimization algorithm like TSP, then wait for that, and I will do it. And if you are interested in some other algorithms-related, competitive programming-related content, then please subscribe to this channel. And also in the description you can find my Facebook page and Discord channel where you can talk with me. So and sorry for issues with audio at some point, but I hope you had a nice time with me. So see you in some other stream, and maybe see you at the top of the leaderboard one day. Good luck in the competition, and bye-bye.